Hello, this is Mr. Waters, and I'm here to give you a rundown on symmetry tests for graphs and equations. There are, as you know, three kinds of symmetry possible in graphs and equations. Graphs and equations can have x-axis symmetry, they can have y-axis symmetry, or they can have origin symmetry. Now, x-axis symmetry is easy to spot. In fact, all the symmetries are easy to spot if you're looking at the graph. You can see here that here's a graph with x-axis symmetry. X-axis symmetry simply means that the x-axis acts as a line of symmetry for the graph. It goes straight through the middle of it, and so that the bottom half would fold onto the top, and the top half would fold exactly onto the bottom, so that if you were to flip the graph over the x-axis, it would look the same. You wouldn't be able to tell the difference. Y-axis symmetry is the same, except that the y-axis is acting as the line of symmetry. I can flip the right side onto the left side, or the left side onto the right side, and they fold exactly onto each other, and if I were to flip the graph over the y-axis, you wouldn't be able to tell the difference. It would look exactly the same. In the case of origin symmetry, is a kind of rotational symmetry, really. If I rotate the graph 180 degrees like that, in this graph, the upper quadrant would rotate to the lower quadrant would rotate exactly to the upper quadrant, they'd rotate precisely onto each other, and again it would look exactly the same. So if you can rotate the graph 180 degrees and it looks exactly the same, then that graph has got origin symmetry. Okay? Now technically that means that you're really flipping the graph over the x-axis and the y-axis, but it's easier to see it as a rotation of 180 degrees. So in order to test the symmetry by using a graph, you simply look at the graph and observe if the graph has the kind of symmetry that we're looking for: x-axis, y-axis, or origin. Now, it's a little bit more work if you're given only the equation and you don't have the graph. Okay, so for example, in that case you have to perform what are called symmetry tests. Now, let's say you have this graph here, or this equation, y is equal to x squared. And I want to determine what, if any, kind of symmetry that the graph of that equation would have. Well, to do x-axis test, I substitute opposite y in the equation wherever I see a y, and then I simplify it. And if the resulting equation, the new equation, is the same as the original equation, then it has y-axis symmetry, then it has x-axis symmetry. So for instance, on this one here, I'm going to go ahead, substitute opposite y in where the y is. The x stays the same. Okay, now I simplify this by getting y by itself, so I'm going to do this part in blue. I'm going to multiply both sides by -1 to get that y. Negative times negative is positive. Okay, y is equal to x squared. Okay, or rather, negative times positive, that's negative x squared. Okay, now you can see that this equation is not the same as the original equation, so this equation, were we to graph it, would not show x-axis symmetry. Now let's try this graph here, or rather this equation. Y squared is equal to x. Just plain x. Now I'm going to go ahead and substitute opposite y where the y is, and there we go. Parentheses, there's the opposite y where the y is. Negative times negative is positive, so that's y squared. When we simplify that, notice that the original equation is the same as the resulting equation. So yes, that equation, or rather the graph of that equation, would have x-axis symmetry. Now in the case of y-axis symmetry, I simply substitute in the equation. To do the test, I substitute opposite x wherever there's an x. So let's say it's going to be, let's do this one again, y equals x squared. The y stays the same. opposite x goes where the x is. Negative times negative, still positive. Y is equal to x squared. You can see that the resulting equation here is the same as the original equation, so we're going to say, we would write, yes, it has x-axis symmetry. Yes. Now notice that it's very important here that you must show your work. You have to actually show the work on this. Write out what the test is like that. Write out what the test is like that, so you can show that you performed the test. You can't just look at it, unless you're given the graph, of course. You can't just look at it and say, yes, that has symmetry. Now, origin symmetry, you're going to do both. You're going to substitute opposite x wherever there's an x into the equation, opposite y wherever there's a y, simplify it, and if the result is the same as the original equation, then we can say, yes, it has origin symmetry. So let's try this one. Y is equal to 3x cubed. Well, I put opposite y where the y is, opposite x where the x is, and I simplify it. Now, this is opposite x to the third power. That's going to be negative times negative times negative, which is negative. So that all simplifies to give us negative 3x to the third power is equal to opposite xy. Now we can see that the negative sign on the left and the negative sign on the right will cancel out, leaving y is equal to 3x to the third power. That's the same, that's identical as the original equation, so we can say, yes, that has y equals 3x to the third power has origin symmetry. And again, we would make sure we got to show the work. We can't just state the fact. We have to show the work and then state the result. Okay, now, a couple of points and then I'm done. First off, and we'll do this black here. First off, it's entirely possible for graphs to have no symmetry at all. Okay, you've got to perform on any given equation all three tests. They might fail all three of them. Okay, and if they do, we would say no symmetry. Too bad. Okay, and that's going to happen lots of times. Okay, or there can have more than one. It's entirely possible for graphs to have more than one kind of symmetry. Okay, so for instance, we can have an equation that would have x-axis symmetry and origin symmetry, or y-axis symmetry and origin symmetry, or possibly all three. So you've got to do all three tests to make sure that you've got all the symmetries worked out. Okay? Alrighty, and I think that's it. Thanks for listening. Talk to you later.